Hey, so I decided I should probably put a screencast out just to help you with the two math ideas that are new to this unit that we haven't done in other units. So I just want to talk a little bit about the calculations that are going to be on your next assessment and on the AP test when it comes to energy specific calculations. Okay, so the first thing is efficiency. You can definitely count on being asked about efficiency on the AP test because efficiency is definitely a key idea for how to get ourselves a little bit of breathing space in terms of both climate change and extending our reserves of fossil fuels. So here's how we're going to calculate. Just remember, when you're calculating efficiency, it's always the output divided by the input. So the top number should be a smaller number than the bottom number. If it's not, you're doing something wrong because second law of thermodynamics tells us we're always going to end up having some energy lost to heat, and so the output value should always be less than the input value, and then we multiply it by 100%. So when we do this, we're usually going to express these units of output and input in terms of, say, kilowatts or watts. So it could be in terms of power. I could do it in terms of joules or kilojoules, kilowatt hours. Any one of those I could put as the input and the output. So when I actually do the calculations, I'm just going to say the output is usually the electrical output of a system. It's usually what it's going to be. It could be kinetic energy produced by a car, but usually not. It's usually going to be electrical energy that's produced almost always in this unit. Okay. And the input can be a variety of things. It could be the heat content that's present in, say, coal, or it could be the amount of uh, potential energy lost by a dam, by the water coming down into a dam. It could be the amount of light energy striking a solar panel. But this is the non-electrical part of the input energy, and the output is usually going to be electrical energy, and it will be smaller than the input. Okay, so that's really all you have to know for for efficiency. It's really just dividing the small number by the big number. Now, this one here, if you're taking calculus, you're quite familiar with this, but otherwise you may not be. So, finding the area under a curve is a pretty easy estimation to make. Now, in calculus, you have to integrate to do that, but we're not going to worry about that. What we're going to do is say this: this is specific in this unit. It's usually specific to solar panels, but we could do it for other things. But usually we're going to do it with solar panels because we get a pretty even curve. All right. And so what we do is we say, look, if you look at this axis here, the y-axis is in kilowatts. So that's thousands of joules per second. And this is hours of the day, which is in hours, but you could convert that into seconds. So what you see is you're just off of joules. Okay, so it's telling me how much energy was produced by this particular device. Okay, so what produced was sent out of it in the form of electricity. So if I multiply the y-axis by the x-axis, I get area. And the thing is, I want to find the area that's just what's under the curve, under this blue line. All right. So here's how I go about doing that. I imagine a rectangle that's as high as the high point on the graph, or the maximum of the graph, and I make it as wide as the base of the curve. All right. And so then I just calculate the area. I just say, well, what is the area of this rectangle here in terms of kilowatt times hours? So, and then what I have to keep in mind is this area here and this area here are not under the curve. So what I do then is I divide the results in half. That's an estimation, but it's a pretty reasonable estimation. This area here is roughly half of this area here. That's the idea. Okay. So then when I get to this one here, let's just do a calculation. So I look at this, I say, well, the maximum height here is this rectangle I've drawn. It has a height of 400 kilowatts. It has a width of 18 minus 6, that's 12 hours. So I'm simply going to say 400 kilowatts times 12 hours divided by 2 because I don't want the whole area. I just want this part of it. And that gives me an estimate of 2,400 kilowatt hours. All right. Those are the two new things you have to do on this unit. So hopefully it won't be a problem when you take the test next week. Thanks for watching. Bye.